All right, in this video, I'm going to attempt to go over the difference between dependent and independent events. So you have two events, like multiple events. Like in this case, you get like the first card is an ace in this Texas Hold'em game, and the second event would be the second card is an ace. Okay, and you're not replacing the card. So these two events, first card being an ace, second card being an ace, these would be example of dependent events, because the probability of this second card being an ace depends on what happens with the first card. Okay, so the first card being an ace is 4 out of 52. Okay, but then one of two things can happen. You can get an ace, right? And if I get an ace on the first card, sorry for the bad handwriting, but if I get an ace, then my second card being ace is 3 out of 51. All right, that's my chance of the second one being an ace. And then if I don't get an ace, if there's no ace, right, then there's still 51 cards left, but now there's all 4 aces left, so it's 4 out of 51. So this is what they mean by dependent, is your chance of getting an ace on the second card depends on if you got an ace on the first card or not. So these two events are considered dependent. Okay, I'm just going to keep doing examples in hopes of getting it. So it's kind of a similar idea with two hearts, right? So your two events on this one, just to be 100% clear, would be first card heart, and then second card heart. Okay, and it's the same thing. This is actually going to be dependent, right? Because your first card being a heart is there's 13 out of 52 hearts that are hearts, or 1/4. Okay, and then again, the second card being heart would depend on if you got a heart on the first card or not. So if you did get a heart, then the next time around, there's only 12 hearts left out of 51 cards total. Okay, and then if you didn't get a heart, then your probability is going to be 13 hearts left out of 51 cards. Okay, so again, this probability on the second depends on what happens on the first. Okay, and if you want an example of independent, so this one again would be dependent, and this one down here would be an example of independent, where when you flip the heads, that is always 1/2, right? Your chance of getting the heads is always 1/2, regardless of what happened on the first card, right? Your chances of getting a jack, I think there's 4 jacks out of 52, okay? But then the second event, whether you get a jack or not, is still 1/2. It's always 1/2, whether you get a jack or there's no jack. Okay, and that's what we mean by independent, is the flipping of the heads or flipping of the coin has nothing to do with what happened in the first event, drawing a jack. It's still 1/2 no matter what happens on the first one. Okay, so flipping a coin is actually another good example of independent, right? So the chances I flip a heads, and then we flip another heads, that's again independent, right? Because your chances of getting the heads the first time is 1/2, and then your chances of getting the head the second time has nothing to do with whether you got a head here or a no head, right? No matter what happened on that first flip, sorry about that, that should be an H, the terrible H. But the chance of flipping another heads is still 1/2 no matter what happened on the first one. So the second flip is independent of the first flip. Okay, so here's two more for you to think about and try to label them as dependent or independent. Okay, and so these first two are independent, basically because, it being sunny has nothing to do with whether you ate pizza that day. It's not like you eat some pizza and all of a sudden it's sunny. That's not how it works. So these two events are not related. Maybe I'll type it to make it clear. So that's independent. Okay. And then the second one's a little bit trickier here, but I would say this is dependent, right? Because your chances of being like if you're pulling a student at random and you want to figure out if they're tall, it would matter if they're in first hour or not, right? Because if you're pulling, maybe this is a poor example, but if you're pulling from first hour, then your chances of being tall is different than if you pulled from a different hour. So you being in first hour or not would then change whether or not they're tall, because first hour might have a lot of tall kids, so your chances of being tall would depend on if you're in first hour or not. All right, so that's what I was trying to go for there with dependent.